Welcome friends, and welcome back to Katie's Camp Kitchen. On our quest to find more efficient ways to cook while camping and at base camp, I wondered, is it possible to run a microwave oven with a small portable power station, one with an inverter that is as small as 600 watts? The answer is yes. In this video, I will share the equipment used, a quick summary of results, and a set of short video clips of heating water, cooking potatoes, a frozen dinner, and fresh corn on the cob. Then we will discuss the results with power, energy, and time information. Stick around until the end for bonus information where I will show you how you can figure out the type of microwave oven to use with small power stations that you may already own. For this experiment, we used two different portable power stations, an EcoFlow River Pro and a Bluetti EB3A. The microwave used is an inverter type microwave. The type is very important. Finally, we used a power monitor to collect the data. Shown in a subsequent portion of the video are the solar panels we used, two X-Star 100 watt solar panels. All this equipment was purchased, and this video is not sponsored in any way. Amazon affiliate links for all the equipment used are in the description box of this video. Here is a diagram of the inverter microwave with its measurements. It weighs 21 pounds and has 0.8 cubic feet of interior space. The turntable plate inside is 11¼ inches. The cooking power is 950 watts. The dimensions are 19.2 inches wide, 14.81 inches deep, and 11 inches high. This is a Panasonic inverter microwave oven, model NN-SD372S. This is a summary of the experiment. Later in the video, we will revisit this chart and the results. The Bluetti EB3A was operated at power level 3 out of 10 and a maximum power of 550 watts. The EcoFlow River Pro was operated at power level 4 out of 10 and a maximum of 698 watts. In this chart, you can see how long each food type took to cook, the temperatures reached, and the total energy in watt hours that was used. These results show that the microwave is a very energy efficient way to cook. Now, let's look at a few short sample video clips. I show how the data were taken and the testing setups. The first video grouping is using the microwave installed in the camper and powered by the 600 watt Bluetti EB3A. A frozen dinner was cooked, as well as fresh corn on the cob. Both were removed directly from the freezer or refrigerator with no time to warm other than in the microwave. The corn would have taken less time had it not been previously refrigerated. This next video sequence shows cooking baked potatoes powered by the 800 watt EcoFlow River Pro. So after 10 minutes on power level 4 with the baked potatoes, we've used 108 watt hours. We do have a good amount of sun right now. We have 188 watts coming in from the solar panels, and the power station's at 64%. So I'm going to cook them for another 5 minutes. And that was generally how the testing went. Taking measurements for each of the power stations, recording temperatures, recording power and energy, and putting it all in graphs that we can talk about now. The summary chart on the left is one you saw just before the video clips. To the right, I charted the data so I could better visualize what was going on. The takeaway from the top chart is that both sizes of power stations used about the same amount of total energy in watt hours, though they were using different amounts of power to cook the food. The second chart that's on the bottom shows how much time it takes to cook different items depending on the amount of power input. As you would expect, less power means a longer cooking time. Still, these are acceptable in many cases, especially if it means not starting a generator. Even though lower cooking power levels are being used with the power stations, this is how I generally use a microwave anyway, except for water heating. When hooked to shore power or using a larger power station like a EcoFlow Delta 2, for example, you would be able to run at power level 10 and achieve the cook times just like when tied to the grid. At this point, you may be asking yourself, Katy, how can this possibly work? How can a 950 watt microwave be operated by a 600 watt power station? It works because we are using an inverter microwave, not a traditional one. On the left part of this diagram, one sees what happens with a traditional microwave. It operates such that it is either on at max power or off. There is no in between. To get lower power levels, like medium and low, the microwave is actually turned on and off very quickly during the running cycle. This is represented by the pink pulses that are shown at 100% power. On the right side of the diagram is the inverter microwave, and we can change the power to the desired level and it steadily stays there, no pulsing. This is illustrated by the green bar, where the power is stepped down and continuously runs. All this can be summed up by saying that in the traditional microwave, time is varied, while with the inverter microwave, the power is varied. Microwave cooking power definitions can be confusing. Let's try to sort them out. Cooking power is the number that's on the front of the microwave box and on the microwave itself, typically on the front. The power consumption is on the back of the microwave. This was tested by the manufacturer to a set standard test procedure. If you use a watt meter and measure how much power the microwave is consuming, it will very likely be different than the power consumption from that test procedure. But we can calculate the maximum power we'll need to run the microwave on high. In order to calculate what that number is going to be, to see if you can run this inverter microwave on your power station on high, you want to take the cooking power, which in the case of my microwave is 950 watts, and add 60 to 70% more. This will tell us the power in watts that we need to run the microwave on high, regardless of if it's an inverter microwave or a traditional microwave. Of course, the beauty of the inverter microwave, again, is that we don't have to have that maximum power all the time. We can run it on power level 5 to get medium or lower, etc., and be able to run off-grid with the smaller power stations. And here is a very quick video segment taking this power level versus power consumption data. As we near the end of this video and get ready to land the plane, let's switch gears a little and talk about portable power stations that will operate with one of these inverter microwaves. This chart shows some of the more well-known manufacturers of power stations and the models that would run this inverter microwave. The main requirement is that the inverter in the power station be at least 600 watts so that you can operate at the minimum level 3. If you want to operate at higher levels, then you'll need a larger inverter in your power station, aka more watts. The second item is the battery size. The larger amount of watt hours the battery contains, the longer the runtime of the microwave and other appliances. Several manufacturers now have extender batteries so that the microwave can be run longer. The other alternative is to consider adding your own extender battery. Jason, who has a great YouTube channel named Jasonoid, has several videos where he shows you how to add extender batteries in different scenarios. Please check out his great channel. The power station shaded in yellow were used in the experiment. If you already have a power station that supplies at least 600 watts of power, chances are good that it will run this particular microwave. Just wanted to touch on one more topic before we discuss our final summary and conclusions. And that topic is solar input. We were testing on a hot day, at least for New Hampshire, 90 degrees, and we were testing on asphalt. So we had quite a bit of solar loading and heat coming up from the asphalt as well. The 800 watt power station that had the larger battery, 768 watt hours, operated for about an hour and a half while I collected data. Operated normally through all testing with 150 to 180 watts of solar coming into the power station, while we were using 685 watts to power the microwave at power level 4. The 600 watt power station, which was actually operating at about 550 watts, also had 150 to 180 watts of solar coming in. At the 4-minute mark, the power station overheated and gave an indication of that. The temperature protection circuits worked. This particular unit actually went into protect mode because I was running it at its limits. It was really close to the output power, as well as putting almost the max amount of solar in and sucking almost the max amount of power out. So this little power station performed excellently, and after it cooled down, it charged normally, and it's run normally ever since over the last month. So really impressed with how it did with this overload situation. In terms of pros and cons of picking a traditional microwave versus an inverter microwave, I would say that the pros are basically all in the column of the inverter microwave if you're trying to run it off grid or with a portable power station while you're boondocking. The only con I see to it at this point is cost. The inverter microwaves run about $200 plus or minus for the smaller sized ones versus $50 to $100 or so for a conventional microwave. Today they weigh about the same for similar size. As far as longevity goes, of course, the traditional microwaves have been made for many years, but the inverter microwave was made for over 10 years, and the patents were first approved in the early 2000s. The other advantage to the inverter microwave is that no longer do you need to run a very large inverter such as a 2000 watt inverter to run the microwave. Oftentimes the microwave is the driving factor in choosing inverter size, and that requirement can now be lessened for camper or off-grid system build. One final advantage of the inverter microwave is the consistent heating throughout the food product. On the left you see the traditional microwave where we have food that is hotter on the outside than on the inside and has that traditional cold spot. On the right you see the inverter microwave where the food is heated more consistently throughout. This is great for bakers that are melting chocolate or butter. So in conclusion, does this inverter microwave work well for our needs? I give that a resounding yes. It works great boondocking, it works great for off-grid, we can run it with a small system versus having to have a large inverter to run the microwave. This inverter microwave is also great for camping when we don't want to run propane inside or crank up the generator on a quiet morning. With this inverter microwave, we also are no longer driven to get a very large inverter just to run the microwave. And if we don't need a large inverter for anything else, it's a real win, because not only do we save cost by not having to buy the larger inverter, but we also save the energy that inverter would have taken and the size that it would take in our small camper build. So to answer my original question, this 950 watt inverter microwave oven can be operated successfully with a small portable power station, such as a 600 watt power station and up. In case you're looking for this microwave or other things I've talked about in this video, I've included Amazon affiliate links in the description box of the video, and hopefully that helps you in looking at specifications, etc. Thanks so very much for watching. Please consider giving us a thumbs up if you learned something new today, and please consider subscribing. We'll see you around the campfire very soon.